The Linux kernel. In this nugget, we're going to talk about the Linux kernel. We'll start by talking about the structure of the kernel, and then we'll concentrate on kernel modules. We'll talk about how to add and remove kernel modules, and also about module dependencies. Then I'll give you some pointers on how to upgrade your kernel and point you to some valuable resources that you can reference if you are upgrading your kernel. So let's get down to it. Well, so what is the Linux kernel? Well, some people would say that the kernel is Linux. The kernel is the base part or the core part of the operating system that takes care of all the dirty work. All right, so when you go to read or write a file to your hard drive, well, the kernel is what's taking care of that low-level stuff. It's interfacing with the disk controllers and sending the data to the disk controllers. And then when it reads data off the disk, there's, file system drivers that are located in the kernel that understand how to interface with the format that the disk is giving it, based on whether it's an ext2 file system or a riser file system or something like that. So the kernel takes care of all of this dirty work, and that's what's common to all the different distributions of Linux. Now, that being said, the different distributions of Linux can take the base Linux kernel that Linus Torvalds distributes out to the community, and they can tweak it a little bit. And they certainly, different distributions certainly add on all this extra functionality to their distribution of Linux, like all these graphical user interfaces and these tools, these configuration tools, and so on. Okay, but the thing that is shared amongst all the different distributions is the kernel. So that's why I'm saying the kernel is Linux. Now, remember that kernel version numbers go like this. There's a major version number followed by a dot, followed by a minor version number, followed by a dot, followed by a patch number. Okay, the version that's on my SUSE machine is 2.4.20. All right, so this is saying major version 2, minor version 4, patch number 20. The second number here is an important number, all right, this minor patch number. If that minor patch number is an even number, like 0, 2, 4, 6, or 8, then that's representing a stable kernel that you can use, that the normal user can use. All right. If this minor version number is an odd number, 1, 3, 5, 7, or 9, then that's representing a developmental kernel, and you really shouldn't be using a developmental kernel in any kind of a setting. I mean, if you're a programmer and you're, you want to mess around with stuff, you can have a developmental kernel in place. If you have some brand new piece of hardware that's not supported by Linux yet, but they're trying to add it into the next kernel, then you might want to have, a developmental kernel in place to try out this new hardware. All right, but basically what happens is, like the 2.5 version of the kernel, once they add stuff into there and then they're happy and it's all stable, then they'll release that as the 2.6 kernel, and then the 2.7 kernel will sort of start up, and that's the new developmental kernel. So there's always sort of two minor versions of the Linux kernel in place, a stable version and a developmental version. Now let's spend a little bit of time talking about monolithic versus modular kernels. So the kernel has all of these things that it needs to be able to accomplish, right? It needs to be able to interact with different devices. It needs to be able to interact with different kinds of file systems and things like that. Well, let me draw this here as sort of all these little boxes represent some little piece of functionality that the kernel has to have, right? It has to be able to interact with ext2 file systems and ext3 file systems. So it has different little pieces for that. It has to be able to interact with different hardware devices and so on. So one approach to building a kernel is to put all of this functionality into the kernel. And then that's what we would call a monolithic kernel. The monolithic kernel has all of the possible functionality the kernel could ever have to do built right into the kernel. Well, now that creates a really large kernel. A monolithic kernel can be really large, and that largeness makes it slow and it makes it consume a lot of memory. All right, so that's not necessarily desirable characteristics for a kernel. You want your kernel to be fast. All right, because it's at the base, it's at the core of the operating system. So if your kernel's slow, the rest of the operating system is going to be slow as well. And Linux was a monolithic kernel back in the day. Back in version 1, 1.1, even 1.2, I think, was a monolithic kernel. But by the time version 2.0 of Linux came along, then it became a very nice, streamlined modular kernel. And a modular kernel has a very small what we call a base kernel, and then it has all these modules around, okay? And these different modules, when we need some extra functionality to our base kernel, then we can just sort of plug in these modules to our base kernel. This keeps our base kernel, or the kernel itself, it keeps it very small. It gives it all the functionality it needs because we can load in as many of these modules as we need. All right, and it just turns out to be a more streamlined kernel. It takes less space, it runs faster, things like that. The only drawback to a modular kernel is that it takes a little bit more work to build it, to make it so that you can just plug these things into the kernel. But for us users, you know, all the programmers did this work so that we can plug all these different modules in, so we get to just reap the benefits of a modular kernel, the fact that it's smaller and streamlined and faster. Now, what are these modules? What are they used for? Well, modules are used for device drivers. So if you get some new piece of hardware and there's no driver for it in your base kernel, then you need to find a module that somebody's written for this hardware device, and then you need to plug that module in, you know, insert that module into your kernel, and then you can use your new hardware device. File system drivers. Every file system format that's out there, ext2, ext3, riser, all those different file systems will have a module that allows the kernel to interact with disks that have that file system. And then system calls, things like disk reads and disk writes. All of these things are modules to the base kernel. All right, so now that we understand a little bit about monolithic versus modular kernels, now let's talk about how do we manage these loadable kernel modules. Now, the module files are located in /lib/modules/ the kernel version number, which, like I said, for my SUSE machine is 2.4.20, and then there's some various subdirectories there. You can go into the drivers subdirectory, and there you'll see all the different drivers for your system and so on. We'll poke around in this directory when we go out to the Linux screen. And then there's a series of tools out there to load modules, unload modules from your kernel, display information about modules, and so on. Now these modules here, these tools here, insmod is for inserting a module into your kernel. Removemod is for removing a module from your kernel. lsmod lists all the installed modules. Modinfo gives you module information, as you could probably guess. Modprobe is a way to do some of these tasks that these other commands do, and we'll look at that when we get to the Linux screen. I'm just going to punt on that for now. You'll see how it's different from these other commands once we get out to the Linux screen. And then there's depmod. Now, depmod has to do with module dependencies. Sometimes a module will depend on another module already being loaded so that it functions properly, and depmod keeps builds these dependency lists. And so if you try to insert some module into your kernel, there will be some message there that says, well, this other module also has to be inserted so the module you want to load will function properly. And depmod is a command that we can use to help that happen so that we don't load modules that have dependencies and then just wind up with errors. All right, so now let's move out to the Linux screen. Let's look at some of these tools. Let's poke around in this directory and so on. Okay, so here we are on my Red Hat Linux machine, and the first thing I want to do is I want to go to the lib modules directory. Remember, it's lib modules followed by your kernel version number, and then once you get in there, you can see some other directories and some files that the modules tools use. Okay. Now, what we want to do is go down into the kernel directory, and in there, you'll see a bunch of different subdirectories, okay? Directories for drivers, file system stuff, things like that. Okay, so what I want to do is show you how to use some of these commands, these tools that deal with modules and loading them and unloading them and so on. All right, so one thing that you can do is insert a module into the kernel with the insmod command. And the easiest way to do that is just to follow insmod by the name of a particular module that you want to load. Now sometimes this is really easy. You just type insert mod followed by the module name and it loads up. All right, but what I want to do here is I just want to show you something that could possibly go wrong in this process, and then we'll talk about how to troubleshoot this and how to fix it. All right, so if you're going to do some sort of MS-DOS file system interaction on your Linux machine, there's an MS-DOS module for the MS-DOS file system. All right, so if I say insert mod MS-DOS, I could also say MS-DOS.O. That doesn't matter either way. I hit enter here, and I get this whole slew of errors. Okay, let me just scroll back here a little bit so we can see exactly what happened. So it said, okay, I'm using live modules 2.4 blah, kernel, fs, MS-DOS, MS-DOS.O. All right, so that's the file that I want to insert. That's the module that I want to insert into the kernel. All right, but I'm getting all of these various errors, unresolved symbols, and fat blah 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 blah. Okay, so here was a problem that you can run into when you just use insert mod, and that is there's some dependency out there that's not being satisfied. All right, so the way around this is to insert the module that will give us all of these unresolved symbols. Now, the unresolved symbols come from a module called fat.o. Again, you can insert that module with the insmod command. You can say fat or fat.o. And it says here, using live modules 2.4 blah, kernel, fs, fat, fat.o. Okay, so now that module has been loaded into the system. If I go back and now do my MS-DOS insertion, and I say that, now it says using this module, perfect, no error message, perfect. Okay, so now what I want to do is just show you, if you look in the proc/modules file, it will tell you all the modules that are loaded in the system. All right, and the modules that are loaded in the system, if I scroll back here a little bit, you'll see FAT and MS-DOS are both loaded into the system. All right, this has to do with the size of the module, and then over here, this is, what's depending on this module or whether the module is being used at all. So here it's saying MS-DOS is unused right now, and the FAT is being used by the MS-DOS module. All right. The other thing that you can do is do an ls mod, and that basically just prints out the exact same thing. It prints out the proc/modules file. All right, this is just another way to view this, and we're getting the exact same information. All right, now what I want to do is I want to try to remove a module with the rmmod command. If I try to remove the module fat, I'm going to get an error message that says, sorry, the device or resource is busy. And if we scroll back up again, the reason that it's busy is because the MS-DOS module uses it. So the rmmod command won't let me remove that module because some other module depends on it. All right, so if I go down here and I use the remove mod command to remove MS-DOS, it did it. Okay, if we go back up again and do an ls mod command, you'll see that the FAT module is there, all right, but it's not being used by anybody, and the MS-DOS module is gone. All right, so because the MS-DOS module is gone, now no one is depending on the FAT module being there. And so now what I can do is I can say remove mod FAT, and now it removes that module. Again, do an ls mod, I scroll back up, and the FAT module is now gone. Okay, so there's the basic way that you can use insert mod and remove mod. There are dependency problems, though, that can creep up. And now let's talk about the mod probe command and the dep mod command. All right, so now let's look at the mod probe command, which basically does a smart insertion of modules into your kernel. All right, so remember now that I've removed the MS-DOS and the FAT module, so we're back to square zero in some sense. And right here, what I'm going to do is I'm going to say mod probe MS-DOS. So if I say mod probe MS-DOS, I hit enter. I don't get any error messages. All right, let's take a look at the proc/modules file and scroll up a little bit. And in that proc/modules file, you'll see the MS-DOS module is loaded, but also the FAT module is loaded. All right, and I only did a mod probe of MS-DOS. All right, now what happened here is that mod probe looks at this file called modules.dep. That stands for dependency. All right, and the modules.dep file is created by the dep mod command. So dep mod will go through all of your modules in the system and create this dependency file so that mod probe can look at that dependency file and then load the necessary module. So when I want to load MS-DOS, it goes automatically and loads the FAT module as well. And this gets around the problem before, right? Of, I went to insert mod MS-DOS, and then I got all these error messages, and I just knew that the FAT module was dependent on it, okay? That MS-DOS was dependent on the FAT module as well, so I went and inserted that. But there's no way that, it didn't give me an error message saying, please load FAT first, right? It just told me what all these unresolved symbols were. So mod probe is a smarter tool than insert mod, and it does that loading for us. It does that check for us. So let's take a look at the, let's go up one level here, and let's take a look at the modules.dep file. All right, if I print that out to the screen, okay, let me just do that through the more command here so that it doesn't scroll off the screen. You'll see the kind of stuff that's in here. Okay, and it's kind of cryptic, right? It's telling you what files depend on which other files. So if I do a search in this for MS-DOS, we'll come down here, and you can see here that lib modules 2.4 kernel fs MS-DOS, MS-DOS.0 is dependent upon lib modules blah, 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 fat.0. Okay, so that's the line in modules.dep that tells you, the mod probe, exactly what it needs to load prior to loading the MS-DOS module. The one command we didn't talk about so far is the mod info command, and you can just give, you can just mention a module here like mod info MS-DOS, and it will give you the information about the module, where the file's located, the description if there is one written, an author, and what license it's covered under. Okay, so that's a very simple command. You can use that on any of the modules in the system. And remember, we didn't actually run this command, but the dep mod command is the command that builds that modules.dep file that we just looked at. Okay, and this runs when the system starts up so that the module dependency information is always up to date. All right, well, now let's talk about what you need to do to upgrade the kernel. And you can upgrade the kernel either by just sort of installing the latest version of a kernel, or you can patch a kernel. And patching a kernel means you can take it sort of up one notch. So if I have the 2.4.20 kernel, I can patch that kernel and take it up to 2.4.21. All right, so down here I've got a bookmark set for linuxhq.com. All right, this is one place where you can get kernel information. Another place that you can get kernel updates is www.kernel.org. Okay, so if you go under the kernel tab here, then it's going to have all sorts of information. So here's production kernels, here's the version 2.6 kernel, here's the version 2.4 kernel, and so on. If I want the latest version of the kernel, and you can see the current version today is 2.6.9, all right, then I can either download the source for that kernel, meaning I'm downloading the source code for the entire kernel, repeating some of the stuff that I probably already have on my system, or I can download a patch for this kernel. Now, a patch, the patch that they're talking about here, would take me from 2.6.8 to 2.6.9. All right, now I'm at the 2.4.20 kernel on my SUSE machine here and on my Red Hat machine. So this patch from 2.6.8 to 2.6.9 wouldn't do me any good unless I also got all the intermediate patches in between. Okay, so when if you're going to patch the kernel, you've got to patch it sort of incrementally. All right, so there's a choice. If you want to upgrade the kernel, you can either download the source or download a patch. If I go under the 2.4 kernel here, and then I look under previous releases, it's going to have a whole list of all the different production kernels, all the different patches that are available for every step of the way. All right, so for the 2.4 kernel, you can see the last 2.4 kernel was 2.4.27. Here's 2.4.26. Here's 2.4.25. And for each of these, you can either download the full source or a patch. All right. Now, that being said, if you're just trying to upgrade your kernel sort of one notch here, or a couple notches, it's going to be a lot faster to download a patch than download the entire source code. All right. Here's what you have to worry about, though, in either case, okay, whether you're downloading the full source code or downloading a patch, is that you have to be careful because depending on what version of Linux you're running, like SUSE Linux or Red Hat Linux are the two that I'm running on my machines, the patches really don't apply to those kernels. All right, the patches apply to what we call vanilla kernels. All right, so like a Slackware kernel or something like that, is a very sort of pure kernel. The Slackware is not adding a lot of stuff into the kernel, and so the patches apply to that version of Linux. Whereas distributions like SUSE and Red Hat do a lot of tweaks to the kernel, and if you try to apply a patch, you're going to run into a lot of errors. It's going to say this was already patched, or this is incompatible, or something like that. Let's talk about what a patch is for a second. I'm going to open up a shell window here and talk about the diff program. So the diff utility is a Linux utility that finds differences between text files. All right, that's the simple way to explain it. Before we look at the diff utility, let's just look at a couple of example text files that I've created. sports1.txt, all right, and sports2.txt. Okay, let me also get rid of this taskbar at the bottom here so we can see exactly what these things say. All right, so sports1.txt starts out football, baseball, soccer, basketball, just like sports2.txt. But sports1.txt then has cheerleading, sports2 has hockey. All right, then they both have wrestling, field hockey, and softball, but sports2 has gymnastics added on at the end. All right, so similar files, yet different. All right, now let's look at the diff utility and what that says for output here. So I'm going to say sports1 and sports2. What are the differences between sports1 and sports2? Another way to understand the output to the diff command is how do I change sports1.txt into sports2.txt? That's another way to think about it. So I'm going to hit enter here, and it gives me some output. Okay, now the output's a little bit cryptic for humans to read, but basically what this is saying is it's saying change the fifth line, all right, and basically take out cheerleading, so that less than sign means take cheerleading out of sports1 and put in hockey to make sports2. All right, and that's exactly what happened. Cheerleading that was the fifth line of sports1, hockey is the fifth line of sports2, and so that's what this little section of the output is telling me to do, to change sports1 into sports2. This part of the output here is saying add a ninth line. All right, and the ninth line that you need to add should say gymnastics, and that's the difference, right? This one ended on softball, this one had a ninth line that was gymnastics. Okay, so the diff program is telling you how to change sports1 into sports2. So what does this have to do with kernels and patching the kernels? Well, patches are just big conglomerations of these kinds of diffs on the files in the source tree. Remember that source files are just text files, and diff works on text files. All right, so what the patch is, what a kernel patch is, it's a listing of the differences of all of the different source files in the source tree, user, source, Linux 2.4, whatever. Okay, and so it's the big conglomeration of all the differences. When you go to apply a patch, the way that you would apply it is you would say something like patch minus p1, and then you use the redirection operator, and then you'd put the name of the patch file. Okay, and the name of the patch file would be something like patch 2.4.21 blah blah blah. Okay, and you have to uncompress the patch file first before you apply the patch. Okay, and it's usually compressed with some kind of zip program like bzip or something like that, or gzip. Okay, so this is how you would apply a patch to your source tree. Now that being said, all these different distributions of Linux that are out there like SUSE and Red Hat would, if you tried to apply a patch directly to the 2.4.20 kernel and apply the 2.4.21 patch, you're going to get all of these errors because Red Hat and SUSE customize the kernel so much that they're not going to recognize in some sense what all these differences are. Okay, it's going to say, give you errors like, it looks like things have already been patched, or I don't see the changes. Okay, and so that's the kind of thing that you're going to run into, the kinds of problems you're going to run into if you try to patch a non-vanilla kernel. All right, well, say that you want to upgrade your distribution to use the latest kernel that's out there. How do you go about doing that if you don't have a vanilla kernel, okay? If you've got one of the kernels that is sufficiently tweaked, like Red Hat or SUSE or Mandrake or something like that. Okay, so what I've done is I found a resource out here for upgrading to the 2.6 kernel. One of the things that I want to be careful of is I don't want to just give you a series of steps that show you how to upgrade a vanilla kernel from 2.4 to 2.6 that doesn't even remotely apply to your system. Okay, so I'm trying to be general here, and the best way that I can do this is point you to an article that walks you through this. And this is good practice anyway, because maybe by the time you are watching this video series, maybe you've already got a 2.8 kernel, and then 3.0 comes out the following year or something, and you want to upgrade from 2.8 to 3.0. Well, following a series of steps to go from 2.4 to 2.6 might not apply as well as you'd want it to. So the best way to go about doing this is to search around in the internet, look at some forums, look for some how-tos on how to upgrade your kernel from the one that you currently have to the newest one that's out there. Okay, so this is the best article that I've found on migrating to a 2.6 kernel. It's a three-part article. Okay, and this first part is all about customizing a 2.6 base kernel. All right, and a lot of the stuff in part one applies to any kind of kernel upgrade that you're going to do. It talks about the makes to do the configuration of the kernel, like make xconfig. Then down here it'll give you some screenshots of make xconfig on and show you exactly what you would expect when you're upgrading the kernel, and talk about the different kinds of things that you might want to configure. I have a bookmark for part two as well. And in part two of this article, they go through and talk about migrating device drivers for Linux 2.6. Okay, and then in part three, they talk about how to apply this upgrade to your current system. Okay, so using the 2.6 kernel with your current system. This is probably the part that's the most different, all right, that would be the most different for 2.6 in particular. All right, and so I would recommend, if you want to upgrade to the 2.6 kernel from some version that you already have, like 2.4, that you go through this series of steps laid out in this article. If you're talking about going from 2.6 to 2.8 by the time you're watching this video series, then what I would do is I would go out onto the internet and look for the latest information on how to upgrade from 2.6 to 2.8. Okay, well, it's time to wrap up our nugget on the Linux kernel. We started by giving an overview of the kernel, and then we started talking about kernel modules. Remember that kernel modules are used for things like device drivers and file system drivers and things like that. We talked about the commands to manipulate kernel modules. Insert mod adds a module to the kernel. Remove mod takes a module away. Remember, mod probe was sort of a smart insert. It took care of dependency information. And remember that you can't load a module if there's some other module that module that you want to load depends upon that's not already in the system. Detmod is something that's run when the system starts up to keep track of all the module dependencies so that mod probe can operate correctly, and then mod info just gives you information about the modules. Then we moved on and talked about patches and upgrades to the kernel. And this is a tricky subject. I showed you what a patch is composed of. It's basically a large set of diffs on all the different source files that make up the source tree. And remember that you can apply a patch directly if you're talking about a vanilla kernel, like a Slackware kernel or something like that. And then the other thing that you can do if you want to migrate your kernel to the newest one is you can upgrade it completely by downloading the entire source of the newest kernel that's out there. Then you can create a separate directory tree in user source Linux, and then you can create a brand new directory tree for this new source tree. You can go through all the steps that I pointed you to in the article to create the new kernel, and then you can have it run, and you can choose to run it from right from the moment that you log in. So you can test it out, and you can keep the old kernel in place in case something goes wrong. All right, well, I hope you found this nugget informative, and thanks for watching.